I'm sorry, computer. Okay, so in summary, we already said this in class, and I'm already losing control of my 6 hour. Okay, so didn't take much. It's like a fly flew by their head. Ooh, a fly. Yeah, that's what I said. Okay. Um, so in synopsis, real fast, a restaurant owner says these are the percentages of people that show up Monday through Saturday, closed on Sundays. You observe this many people show up on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You're going to see, does this data support the stated percentages by the restaurant owner or lack supports? So we're not going to actually do this one, but I thought it'd be a good idea to show what we're doing, like what does this pertain to? I really like to see that biology example that you were talking about, but that's for later. Um, so that you'd understand some of the variables. So one of them is the observed frequency. That's what letter O will be when we look at some formulas. This is the sample data from a simple random sample. We randomly check a week. What would be smart though is if you checked like 4 weeks. More data, more support for whatever claim or not the claim. And it is observed, in this case, the amount of people that show up on Monday through Saturday. And those numbers I just made up, just to try to emulate this. Like I say, we're not going to do this red example. I'm just trying to give you an idea. What does this do? But then the next thing you're going to have to, find, you actually are going to have to find this number. From the sample of all the people that show up, what would be the expected frequency? And I'll break this down with the slide here. As you write this, though, hopefully your mind is in the right spot as you're writing. So Monday you saw 50 people. What would you have expected to find? Well, what you need to do is add up this total week, because we're breaking this down into weekly. How many people show up Monday, percentage-wise, too. So you add up these totals of the observed data, and then for Monday it should be 10% of that total, right? And that would be the expected amount of people that would have showed up Monday. So that's what expected frequency is. When we actually get into actually doing this, actually, I like to say that word a lot. I put an example, and then, this is the formula that, does work. I guess expected sub-I didn't look that up. I still haven't. But it's just each individual expected, maybe that's what it stands for, expectation. So what's the Monday expected value? What's the Tuesday? What's the Wednesday? You are going to have to calculate those. So I did it for instance. I added these made up numbers that I just, threw together this morning. 50 people showed up, 43. Add them all up, and the expected for Monday would be 10% of that total. So the expected would be 42.7. So now, when you wrap your head around this, the actual amount of people that showed up was 50 when you expected 42.7. Are they spot on? Yes or no? No, there's a spread. And that's what this does. The formula that we'll show you next calculates, how far spread out is the actual compared to the expected, and is it so spread out that it doesn't verify the percentages stated by the restaurant owner. I hope this is what happened in biology in some way, shape, or form. Then I'd really feel good about what I'm teaching. Okay, so good to go? I'll press pause for a second. I do see a lot of writers, which is good. Warms my cold black dead heart. Well, you can't, no. You were taking a test. I'm not letting you catch up. Okay, so here we go. All right, so here's what we do. That's why I make a video, right? All right. Gotta worry about the whole amount of people. Okay, so here's number one. It's all gonna be the same, but and I guess I'm jumping ahead of myself. But the H sub O, the null hypothesis, is for that first example, the percentages that the restaurant owner stated are truthful. Or you'd say the restaurant owner says this percent show up on Monday, blah, 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 blah. Then the alternative hypothesis is these are not the percentages that would happen. So it's the opposite of what is stated as percentages that should be mirrored. I don't know if I said that great, but that's you'll see that in the next example. We'll clarify that statement. Step 2, I don't know why. That's the incompatibility of these two. Programs, again, jacks up my animations. But find the degrees of freedom. It's interesting in this particular scenario, the degrees of freedom come from the amount of categories minus 1. So the last example, Monday through Saturday, is 6 days. So your degrees of freedom would be 6 minus 1. Now you picked up that new sheet here today. That's for a chi-squared scenario. Your your row that you would look across is 5 then, if we were doing that day thing, right? Okay, so 6 minus 1 is 5. You'd use 5 for your row. Then you just have to, what's your level of significance? All right, but we'll go over that, and I have some of the images from that sheet that I pulled from the internet as usual. All right, and then you find the critical value from your chi-square distribution sheet and denote the rejection region. And I'll talk about that on the next example, but look at your sheet right now. Look at the bottom of the sheet. Look at the picture that was on the sheet, and then look at my writing. And then the guy on Khan Academy, there's different graphs for different levels of significance. He obviously had some sort of computer software that showed those graphs. Again, I didn't share that video or link it. But just speaking out loud, in general, the graphs kind of look at what's at the bottom, and the critical value for the chi-square distribution sheet separates the rejection region from the fail to reject region. So basically why this is easier, you don't have left tail, right tail, two tail. I guess it's just a right tail, right? I mean, look at it. The rejection region is to the right of that critical value. The fail to reject is to the left. And that's the way we can look at this. So it's easier. I don't care what anyone says. And then the formula is not, it's just 1. And you'll make sense out of this when we actually have an example of this. First of all, what does this symbol mean to the left of this fraction? Summation, you're going to add a bunch of stuff. And then as you write this down, I like to blabber because I like, as you're writing, this is what he said kind of thing. O is, remember, the observed. Now let's take Monday. Let's do that example with the Monday stuff. I observed 50 people coming in Monday. I think I have that number right. Minus the expected, I think was 42.7. Squared divided by 42.7. Now imagine if your expected was 50 and your observed was 50. Isn't that what you want to verify the restaurant owner, right? What's 50 minus 50? 0 squared? 0. 0 over 50? Still 0. And what we're saying is if every observed equaled the expected, then you'd get 0 for this formula, and that means the data perfectly matched what was expected. I just wanted to throw that out there. And those that are listening would make sense out of that. Maybe we can, when we actually see the next example, say that one more time. Then you make a decision and interpret. And again, I guess wait to see how the schematics of this work. And why this isn't hard is it's just a minorly different of almost exactly the same thing. You know, we got a different sheet, different kind of test, different kind of scenario, but the schematics of it are very, very, very similar. Really? Eee. Okay, here we go. I feel like everyone's ready as they're yammering. Oh, look at this. This gets so jacked up. All right, so because these two incompatible formula or situations are here, I'll put the chart down. Isn't that a pretty chart? Yeah. Given to you by PowerPoint. I just asked for a chart and then it made it look like that. So a radio station claims that the distribution of music preferences is as shown below. Marketing executive surveyed 500 people. So if you look at this right here, here is the station's claim. Hit the screen with my finger. I'm surprised that actually. And then, let me get that out of there, just so you don't see that. And I called that step 2. Ooh, it went away, all of it. And then here's the survey that you sent out. These should add up to 500. Hopefully I didn't make a mistake in doing that. Okay, so the station claims that these are the percentages of what people prefer over the years. Well, I'm going to check that. I'm going to do a survey of 500 people. Oh, I forgot to say this. Actually, it'll come up in the next thing. And I didn't. This actually has to be done at some point. So I call this step 0 because really it has to be done before step 4. When you calculate your values, you have an observed amount of people, but you have to calculate the expected. So that's why this is going to come in, or it won't, because the computer hates me. There it goes. I hit it. So step 0, that means you got to do this at least before step 4. You got to calculate what would have been expected out of these 500 people. Well, 4% of them should have liked classical according to this music station. 42% should have liked country. 7% blah, 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 blah. So at some point you got to do this. All right? And then like I was saying before, I don't want to jump ahead of myself. I'll wait till we actually do step 4 to say what I said before. You know, if the observed equals what you expected, you get 0. And then that would mean you nailed this perfectly. And of course, there's a huge amount of support. Oh, okay, there is that thing about conditions. And I got to find this somewhere. Someone else verified. I only read it one more in one place. The 5 seems to be the magic number. These have to be greater than 5, I guess, for you to be able to proceed with this test. So you have to have a large enough sample size in every category that you at least have 5 here, which I find odd, but so I think for conditions, we're just going to say the conditions are met, so we can move on. Okay, so then here's what we have for H sub O and H sub A. Do as I say, not as I do. Don't ever do this again. I just wanted my notes to fit. But the H sub O is what the radio station is representing. And representing that, hey, the distribution of music preferences is 4% classical, 42% country, etc. H sub A is the distribution of music preferences differs from the expectation. And that's what you can say. That one's okay. And then I am being quite rude to those seniors that cannot write a sentence at the end that pertains specific to the question. And I still don't think I've been a good enough teacher to mark you wrong for being lazy about writing complete and nice little sentences for the final situation. So you better get on there. Most people are doing just fine. But I do find that problematic. Step 2, find the degrees of freedom. Well, there's 5 categories. 5 minus 1 is 4. Hey, you can look it up right now. Your level of significance is 0.01. Look across at 4's row. 4 cross-section with 0.01 gives you what number? Okay, so again, where does this come from? Statistics. I don't know. Somebody did some long, convoluted math software pertaining to this specific type of hypothesis test. And this is what they came up with. People much smarter statistically than I am. Smarter in statistics. So I think I have the graph come here. Yes. Okay, good. My memory. So this is what it means. And I'll pull the screen down a little bit in class. It's a little bit cut off. This drives me nuts, this screen. I'll just hold it. So what this means is and I think I said this with you guys. Good, I left it. But on Khan Academy, depending on the level of significance, the graphs look different. Don't worry about that. Areas and all that other stuff. Same old, but a different kind of graph here. This 13.277 is right here. It's right here, sorry. Right where I arrowed. All right? to the right of that is the rejection region for H sub O. To the left of it is the fail to reject. And then someone asked me, is this like 0 right here? And I said, yes. Jake! Okay, you can put that down, sir. All right. So what if it was 0? What that means is all the observed data matches the expected behavior perfectly, right? Didn't I say 50 minus 50 is 0? 0 squared divided by 50 is still 0. And then Monday, Tuesday, Wednesday, Thursday, Friday are all zeros. That means the data is perfect. So that is 0, and then this is 13.277. So this is, again, pertaining to H sub 0. All right, so I did stall for those that are writing. Although the chart does take a while to write, right? Right. Okay. All right, so I pulled this to the next page, so if you were still writing the chart, there it is. Because now it's the formula time. All right, and no whining, blah, blah, blah. You got to take all the categories and take, there it is, I already had it. Okay, you take the observed minus the expected. So this is what I've been saying if you didn't make sense out of that. What if the observed equaled the expected? Then this would be 0. And then what that number, that 13.277 that we're trying to reach, that represents the margin of error between saying evidence supports the claim or doesn't. Again, statistics, crazy. Okay, so 8 minus 20, observed minus expected. That's why you have to do this before step 4. You got to calculate each expected, which is very simple. All right, and then observed minus expected squared plus 20. And then some people, as you're writing this down, you don't really have to make rocket science out of this. On a standard, you don't need a graphing calculator for this. All you have to do is type parenthesis 8 minus 20, close parenthesis, caret, divided by 20, and then type a plus sign and start the next one. And just make sure each one that you type, you have both parentheses, and you don't make a mistake. So after you type it, stop, look, and then move on to the other one. A lot of times getting that fraction button is a pain as well. And then, I will finish this off. Go ahead and test it. You can get this number, 21.649. And then what you need to understand in this simplistic test now is, where does that fall? Does it fall in the unshaded or the shaded? Come on, guys. What was the line? 13.722, I believe. So 21 is greater than that. It's in the shaded. So what does that mean you do with H sub O? Reject it. And what that means, what you got to understand that what that means is these spreads are too far off. They should have been closer. And then therefore this number would have been smaller. And if it was less than 13.7, then the spread is small enough to say there is support for the situation. I think that should make sense. But here's your final sentence that you say. And this might be like the 57th sentence written in this class to make you understand how you answer the question at the end and not be a bum senior that can't write a full sentence. If you're not a bum senior, put your earmuffs on. I didn't just call you a bum if you write your sentences. I'm just saying she looked upset. She looked upset. Okay, since 21.649 is in the rejection region, you reject H sub O. So that means there's a rejection that these percentages are supported. So there is not enough evidence to indicate that the distribution of music preferences is 4% classical, 42% country, 7% oldies, 18% pop, and 29% rock, period. End of story. Hasta la vista, baby.